So after reading the gene therapy comes of ages or comes of age article, a little background information on gene therapy. The research has been going on for about 50 years since the 1970s, and after many setbacks and advancement breakthroughs, it has been shown that gene therapy has had some productive clinical benefits in patients with various inherited diseases as well as acquired diseases such as blindness, neuromuscular disease, hemophilia, immunodeficiencies, and cancer. So speaking of setbacks, in the 1990s there was a lot of trial and error with viral vectors, which ended up resulting in a lot of toxicity. So this led scientists and clinicians to go back to the drawing board, study the basics over again to try and understand what these viral vectors can do, and they've studied virology and genotoxicity effects in that sense, and even they've this article kind of touched base on the basics of viral vectors and how they've advanced to genome editing, to a more modern approach. The viral vectors can really only deal with gene addition, but the genome editing has a multifaceted approach, which can also, on top of the gene addition, can mediate gene ablation and gene correction for viral vectors. So on top of these viral vectors that have been developed, one that particularly shows a lot of promise is the adeno-associated virus, or the AAV. It is the least risky, but also has doesn't have the long-term implications because of it has a small amount of DNA that can be packaged into it. So more onto the author's evidence and data and conclusions. The gene therapies for inherited immune disorders, hemophilia, eye and neurodegenerative disorders, lymphoid cancers, and have recently progressed to drug therapies in the United States and in Europe. Gene delivery in vivo shows promise in clinical trials for the retina and liver via the AAV, as we discussed earlier, which has been helpful in treating blindness and hemophilia, respectively. Neuromuscular targets. There hasn't been a full understanding of Parkinson's disease, which is very common in elderly adults. But there has been a treatment for the childhood onset spinal muscular atrophy, which has shown clinical promise via the drug nusinersen, which acts by alternative splicing on the SMN2 gene in spinal neurons. Another factor that has been talked about in this gene therapy is the hematopoietic stem cell transduction, which has been efficiently achieved through lentiviral vectors in immunodeficiency disorders such as Wiskott-Aldrich syndrome and SCID, as well as the engineered T cells have emerged as medicine for cancer, and CAR therapy, which is the chimeric antigen receptor therapy, have reprogrammed the specificity, functionality, and metabolism of T lymphocytes. But in this, there are some downsides to it because some of the T lymphocytes have, in some cases, led to neurotoxicities and even death in worst case scenarios. Overall, my opinion on the topic of gene therapy and on this article specifically is I felt this article was very unbiased. They did not shy away from mentioning failures as well as successes. And I think that overall, because of the growing technology and through trial and error, the breakthroughs are starting to show for growing inherited and even acquired diseases. That being said, I think that because of the way the article talks about how scientists, clinicians, as well as pharmacists, philanthropists, and the government all kind of work hand in hand on this phenomenon to be able to treat these diseases, and learn more about them as we go, I think that ethically they'll be able to come to a moral understanding and moral common ground moving forward. And I think that this could be the future, but I think that the main thing is that they touch base on the fact that they want to do it safely and make it affordably so they can get it into the people's hands who really need, this type of gene therapy. So I think that they had the right intentions in this article, and it was a very good read. Thank you.